In this portion of the video, we're going to learn how to graph logarithmic functions. Now, one of the things we have to remember is that an exponential graph and a logarithmic graph are just inverses of each other. So if you remember, when you have the graphs of two things and they're inverses, all you have to do is trade the x and the y points. And that's how we're going to start this. I'm on page 33 in our current packet, and this problem here is just log base 4 of x. So there's no transformations present here. So what I'm actually going to do is I'm going to graph the exponential. So I'm going to use -1, 0, and 1, just like we have been for graphing the exponentials. Now, in case you've forgotten, anything to the -1 power just makes it a fraction, so it's 1/4. For the purposes of graphing, if you said 0.25, I would be okay with that because it's just an approximation anyways. Anything to the 0 power is 1, and 4 to the first is just 4. Now, that's the exponential. I don't want the exponential. What I want is the log graph. So to get the log, all I'm going to do is I'm going to flip these points. So these points become 1/4, comma, -1, 1, comma, 0, and 4, comma, 1. So that is actually what I'm going to graph. So 1/4, so it's over just a little bit, and down 1. 1, 0, and then 4 ones. 1, 2, 3, 4, up 1. Now, just like an exponential has a horizontal asymptote, the log, because when you trade the x and the y's, that horizontal asymptote now becomes a vertical asymptote. And when it is not changed at all, that vertical asymptote is the y-axis. And the equation of the y-axis is x equals 0. Now, because this is a vertical asymptote, this line cannot go over it. So the domain is not all real numbers. As a matter of fact, there are no points over here, so the domain starts just past this. So my domain is x greater than 0. For my range, this goes down forever. It goes up forever, even if it is going up at a curve. So my range is all real numbers. So this is an initial logarithmic graph for a base of 4. They're all going to have these same general characteristics. But when you look at number 2, you'll notice that instead of being log base 4, this is log base 3. And with log base 3, I have to change my starting points. Now, -1, 0, and 1 will always be the same. But what they do is something completely different, though. Okay, instead of being at 1/4, 1, and 4, it's at 1/3, 1, and 3. So it's a little different. So I'm going to plot those points right after I convert them to a log. So I flip them. And those are the new points. 1/3, comma, -1, 1, 0, and 3, 1. So 1/3, so it's over just a little bit, and then down 1, 1, 0, and 3, 1. Now, those are the non-transformed points. Now I have to do whatever shift is being asked of me. Over here, there's nothing in front, so I have no vertical stretches or reflections. There's no negative sign in front of the x, so I have no reflection over the y-axis. but I do have a minus 2. Now, this minus 2 is not with the x. It's easily thought to be so. But because this is not in parentheses, this is considered to be behind and outside the logarithm, which means this is a vertical shift. So it's down 2. So all I'm going to do with these points is I'm just going to move them down 2. So 1, 2, 1, 2, and 1, 2. I've drawn in my asymptote. Here's my curved line as best I could draw it. So now I can start saying things. Like, for instance, my domain, the points go to the right, and they get close to 0, so it's x greater than 0. The asymptote is always the variable with the inequality sign, but with equal. The range, this goes down forever, and it goes up forever. So it is y equals all real numbers. So graphing logs is not tough. It's very repetitive, though. Okay? Now, the most common errors people make are they either forget to flip, or when they're trying to graph an exponential, they flip when they should not. Those are the most common errors. So with number 3, I note that it is base 5. So, starting points. Substitute these numbers in. 5 to the negative 1 is 1/5. 5 to the 0 is 1. 5 to the first is 5. So, now to get the log version, I'm going to flip these. And now I'm going to plot them. So 1/5 is over just a little bit. It's somewhere in the middle. I'm not going to measure. And down 1. 1, 0. And 5. 1, 2, 3, 4, 5. Up 1. So those are my parent points. Now, I look up here at my equation, and it has minus 3 in with the x, and it's in parentheses. The parentheses tell you this is intended to be a horizontal shift. So, we still do opposite the sign, so it is right 3. So right 3, so 1, 2, 3. 1, 2, 3. 1, 2, 3. Now, before with exponentials, the asymptote followed any vertical shifts. But with logs, the asymptote follows the horizontal shifts. So the asymptote was also moved right 3. So I'm going to draw that in right now. So I'm going to connect the points. This point right here was part of the original, so I'm not going to include that. I'm going to try to stay under it. And that's my best attempt at graphing this. So now the asymptote is at x equals 3, because that's where it touches x at 3, which means the domain is x greater than 3, and the range, because it goes down forever and goes up forever, is all real numbers.